Previously, we discussed how to select certain elements of our objects using logical values. Yeah, and in our example, it was that we had a vector of length 6. Yeah, and as I showed this before, if we use a vector of logical values, we can select only those elements that we are interested in. Yeah. Also, what I should mention is that the vector of logical values must be the vector or any data structure which is consistent with the primitive object. Here, in our case, it is vec. It must be of the same dimension or the same length. Yeah, and if we want to choose those three elements, yeah, this is what we did before. And now, what is super useful is that we can check whether some conditions are met, and if those conditions are met, then we select those elements. Yeah. So right now I will show you how to check those conditions. This table presents the list of the most basic and most commonly used logical operators. Yeah, and just like all other materials, I uploaded this table and other materials to GitHub. Yeah, and just as a reminder, those materials you can find over here. I hope so. How do those logical tests work in practice? I would say very intuitively. If we take, for example, this condition, we know that this condition is not true. Yeah? And if we ask R to check whether this condition is true or false, it returns false. On the other hand, if we type complementary condition, it will be true. Yeah, and R is quite flexible in using those tests, yeah, because we can, for instance, test not only scalars but also vector objects, or even data frames, lists. Yeah, and example for vectors is here. Yeah, that we may want to check whether this condition is true. So, if we type this line of code, it checks element-wise each of element from vector on the right-hand side. Each element is compared with 2. Yeah, and we see that for the first element, this condition is false, but for the remaining elements, this condition is true. Yeah, so we have the vector of true and false conditions. As I said before, logical tests are quite useful in extracting those elements that we are interested in. And let's use this. Let's create such a vector. Sequential vector from, let's say, -10 to 10. This is our vector, and using logical tests, yeah, if, for example, if we are interested in extracting only positive elements, we can type vec greater than 0, and as a result we will get a vector of true and false values. Yeah, so each element of this vector refers whether this condition is met for each element of this vector. Yeah, and if we want to extract only those elements where this condition is true, we type something like this, and we get only those elements. Yeah, so I think that this is a quite useful thing in R and in other programming languages. In the logical tests, what I should stress is that we have to remember about test for equality. It's not one equal sign, but rather two. And yeah, here, yeah, it tests whether 2 is equal to 1 plus 1. We don't use, creators of programming languages don't use only one equal sign, because one equal sign is reserved for assignment operator. In R, assignment operator is of this form, but also standard equality also works. Yeah? So to eliminate confusion in programming languages, test for equality is made with double equality sign. Let's illustrate logical tests with another example. Let's create a vector of length. Our old vector was of length 21, I guess, yes. And let's create a vector of the very same length from 1 to 21 times 10. Yeah. So we have this vector, and now, for instance, we can suppose that we are interested in this element of y for which in a vector x, vector vec is equal to 0, suppose. So we can write vec equal to 0. We have false, and we have this condition is only true for 11th element, and to extract this element of y for which vec is equal to 0, we can do something like this. Okay, and it should be 11th element. Yep, that's true. Also, we can with equality, with this test for equality, we can check which elements of this vector are even. And to do it, we can use modulo operator with 2. Modulo operator, yeah, for modulo operator in R we use double percentage, yeah, and here we have the result of this arithmetic operation, and even numbers are those for which modulo operator is equal to 0. So we can introduce this test and then extract only those values for which this is true. Yeah, and we have only even numbers from vector vec. The operator that deserves a very short discussion is operator in, the very last one from the list over there. Yeah, and this operator check whether we write it percentage in percentage, and we check, and then this operator checks whether element on the left hand side of this operator is in the set of elements on the right hand side. Yes, and this is example. Here we see that it checks whether 1 is in this vector. Yeah, and we see that it's true. On the other hand, if we type 5, it will be false. What is worth mentioning is that we can, on the left hand side, we can provide a vector of many elements, and then each element of the vector on the left hand side will be checked whether it is in the set on the right hand side. And this is example. Something like this. Yeah. And we check. We see that here we have, it checks whether 1 is in this set, it is, 2 is also in this set, -2 and -5 is not here. So we have true, true, false, false. If we type something like this, we will get what? We will get true, true, true. And I would like to refer to this example to stress the subtle difference between in operator and logical test for equality. In this case, we will have in the former case, it checks whether 3 is in this set of elements, 2 in this set of elements, 1 in this set of elements. While when we use equality test, it checks whether 3 is equal to 1, it's not, whether 2 is equal to 2, it is, and whether 1 is equal to 3, it's not. So it's a very subtle thing here, but it's worth being aware of this. I hope that you remember an exercise where we assign a different value for all cards that are aces. And we had in previous exercises we had data frame, and before we checked manually which cards are aces. And using logical tests, it can be done much easier. And to use this logical test, we can type GF phase, and we are interested in those observations where phase is equal to ace. And what is important right here is that here phase is a character variable, so we have to put this in a quotation. So this logical operator of equality also works with strings. And if we type this, we will have a vector of those rows where this condition is false or true. And here we see that it's true here, 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 and here. And also we can check. So we counted all true elements manually, and also it's not the most convenient way. Alternatively, we can type something like this. This vector is created, and then all elements are summed. And here we have 4. What is important to remember that in this operation we have so-called coercion that we discussed before. That logical elements, all logical values, are converted to numerical counterparts. And true is converted to 1 and false to 0. And after this conversion, we have numbers that we can sum. Yeah? And this coercion happens automatically if we use some arithmetic operation. Yeah? And so because of this sum are automatically converted logical elements to numerical counterparts. Now we can use this vector of logical values to refer to those rows where this condition is true. Yeah? And as a reminder, before we used this quite cumbersome notation to refer to those rows where face is equal to aces, but in contrast to this, we can use basically this notation, this logical notation, and we will get exactly the same result, but in this case we did it manually what R did for us in latter scenario when we use logical test. In very similar way we can refer to elements of the vector using the same system of conditions. And if we want to refer to values of those cards that are aces, we can do it this way. Let's create copy of our data frame, and now if we want to refer to this refers to the column of values, and if we are interested only in those values for which DEC to face is equal to ace, we put this. Notice that in the previous case we put comma because this object on the left hand side is a data frame, while here we take the column of the data frame which is a vector, and for this reason here we provide only a vector of those observations that we want to extract. Putting comma doesn't make sense here because there are no columns here. So now we have those values, and if we want to change those values to, let's say, 16, we do it this way. Yeah? So we assign 16 to all those. We assign 16 to all those values from data frame DEC2 where face is an ace from DEC2. Yeah? And I would like to stress that we cannot forget this thing here. Yeah? That without face we would get error. Yeah? Without DEC2. And so we need this DEC2 to tell R which column from which data frame we refer. Yeah, so this assignment works just like here. And if we type DEC2 now, we see that now values for aces is 16 because of our assignment. Yeah. Now let's do a very simple exercise that will revise what we learned. Yeah, the questions to this exercise you can find over there. Yeah, and in this question we are asked to assign a value of 1 to every card in our data frame that has a suit of hearts, and and in addition to this, we are supposed to assign a value of 1 to every card in our data frame that has a suit of hearts and face of queen. Yes, so first let's do the first question. Yeah, and instead of working on df, let's create a copy of our object, and here we check which elements have suit hearts and we chose those elements and we change the value of those those elements to 1. I created df2, not to change df, okay, but never mind. Yeah, so now we have our data frame df, and indeed all elements with hearts now has a new value equal to 1 thanks to our assignment. Solution to question 2 is slightly more complicated, and to solve this question I will have to introduce so-called Boolean operators. Yeah, and so Boolean operators will replace the content of the question above my head right now. Yeah, and as you can see, those operators allow us to consider more complex sequences of logical statements. Yeah, and we have several Boolean operators that we can use in R. Yeah, and so the first we have AND, OR, exclusive OR, negation or and OR. Yeah, those are the most popular Boolean operators in R. And how it works? It works that if we have, for instance, two logical statements, yeah, which are true. If we want to check whether both are true at the same time, we use this sign. Yeah, and alternatively, OR works in a similar way. So in this case, only this statement is true, but for OR, this is enough. Yeah, exclusive OR is true only if one of the conditions is true. So here it will be true because only the first argument is true, but if we put two true statements, it will be false. Yeah, and so in our question, we will need AND operator, yeah, to check whether to check two conditions. Those conditions are that cards must have a suit of hearts, first condition, and second condition that face of this card must be queen. So in our case will be that we check whether suit is equal to hearts. We have several cards which are heart, 13, and the second condition is that face must be queen. And also we have vector that indicates where those conditions are met. Yeah, and here we will have only 4 cards that fulfills this condition. So overall, we are interested in finding this row where both conditions are true. And in a deck of cards, only one card meets this condition. Yep, it's here, and yeah. So we want to assign new value only for those cards that meet those two conditions. So let's check 41. Before we want to, so overall we know that we will change this value only, yeah, but let's run this and then let's check once again. Yeah, now we have new value for card that meets those two conditions. Yeah, so this is it. The last exercise that we're gonna do today, actually I'm gonna do, yeah, I don't know, you may continue watching this, but for me the day will be over very soon. And in this exercise we are asked to convert some sentences into conditions in R. Yes, so in the first, so we have some conditions here. There is some objects, and in the first case we are asked to check if W is positive. Yeah, our vector W, this is our vector, and to check whether elements are positive, it's enough to run this. Yeah, so this is first very easy question. In the second question we are asked to check whether x is greater than 10 and less than 20. X greater than 10 and less than 20. Our x is here, 5 and 15. So we have for 5 it is false, for 15 this is true. Okay. Question 3 is quite easy in this sense that, yeah, we want to check whether this string, the value of element in this vector is equal to February. Yeah, so do it. it's enough to type this. Okay, and the very last condition, in the very last condition we have a vector of 3 elements, Monday, Tuesday and Friday, and we are asked whether every value in Z is a day of the week. So first we need to write vector of all days of the week: Friday, Saturday, Sunday. Okay, and we check this. Here, what we receive is that this logical test checks if each element is in the set of days of a week. Yeah, but here in this exercise we are asked whether every value in Z meets this condition. So to solve this problem, we need to use operator all. All checks whether all elements of the vector are true. Yeah, and yeah. So in this case, all elements are true. Alternatively, if we had instead of Z, we would create a vector Christmas Z2. In this case, this condition is true for 3 elements, but not for the 4th. Yeah, and then we have false here because it's enough that one element doesn't meet this condition. Yeah, and the whole statement is false. Yeah, so I think that this is it for today. Yeah, so have a nice evening if you watch this in the evening, or have a nice whatever part of the day you are now. Actually, I concluded with Boolean statement. Now I'm wondering whether I should put sitcom laugher here. Yeah, let's do it. See ya.